Hello students, welcome to my video. Hope you and your family members are fine in this lockdown crisis. Today in this video we are going to start our first chapter, number system. About number system you have already learned in lower classes. Just recollect. Natural numbers, whole numbers, integers, rational numbers and irrational numbers.
Let us start with what you have learned earlier about number system. Number system start with natural numbers. Natural numbers. It is denoted by capital letter N, which is the first letter of natural numbers. Natural numbers can be called as counting numbers also, since it starts from 1 to infinity. Infinity can be represented by this symbol, and it is also called as lemniscate. Infinity can be called as lemniscate also. So in sets, when you will write n is equal to 1, 2, 3, etc. up to infinity. So natural numbers denoted by n, which starts from 1 to infinity, it is represented by n is equal to 1 set 1, 2, 3, etc. up to infinity. Next comes whole numbers. Whole numbers is represented by capital letter W, which is the first letter of whole numbers. Whole numbers, only difference between natural numbers and whole numbers is 0 is there in whole numbers, but 0 is not there in natural numbers. So when you will write in the set format 0, 1, 2, 3, etc. up to infinity. So this is the set format. 0, it is starting from 0, here it starts from 1. So natural number starts from 1, whole number starts from 0. Next comes integers. Integers is represented by capital letter Z, which has come from German word Zahlen. Zahlen, meaning is to count. So that is the Z. Now integers means set Z is equal to all the negative numbers, 0 and positive numbers. So negative numbers, negative 2, negative 1, then 0, 1, 2, 3, etc. It continues. So all the negative numbers, 0 and positive numbers include integers. In set format, Z is equal to etc. You have to start, because this way it is negative numbers are continuing. Minus 2, minus 1, 0, 1, 2, 3, etc. It's continuing again. Next comes rational numbers. Rational numbers, which is denoted by the letter Q. Q has come from quotient. Quotient starting letter, that only the symbol of rational numbers. Rational number means it is in the P by Q format. Any number which can be written in the P by Q where Q is not equal to 0 and P and Q are integers, any integer, then we can call that number as rational numbers. So it is represented by Q, which can be written in the form P by Q, where Q is not equal to 0 and P and Q are integers. Example, 2 by 3, 10 by 8, any number in the P by Q form, you can consider it as rational numbers. Next comes irrational numbers. Irrational numbers. Irrational numbers, usually it is represented by IR, I and small letter r, or capital letter P. Since integers can be represented by capital letter I, here we are not taking I to represent irrational numbers. So irrational number means they are non-terminating, non-recurring decimals. Non-terminating, non-recurring decimals. we can say that they can't be written in the form of P by Q. P by Q form, when it comes, it will come to rational numbers. Which cannot be written in the form of P by Q, they are called as irrational numbers. In decimal expansion, non-terminating, non-recurring decimals are called irrational numbers. For example, pi value. Pi value is 3.14159 etc. It's repeating. This is non-terminating. It is not recurring also. Recurring means the same number will be repeating. That is called recurring decimal. This is non-terminating. Terminating means it will stop. For example, 1.25. It is stopping here. So if it is terminating, it is not irrational number. So non-terminating, non-recurring decimals are called irrational numbers. Another example, if you say, means all the square root of prime numbers, root 2, root 3, root 5, all comes under irrational numbers. Now next one, last one is real numbers. Real numbers. This is denoted by the letter capital R. Real numbers means all these whatever you have learned right from natural numbers, all numbers together we will call it as real numbers. In short, all rational and irrational numbers and irrational numbers form real numbers. So real numbers represented by capital letter R, all rational numbers and irrational numbers together form real numbers. I will show you in one diagrammatic form. See, this circle, small circle, denotes natural numbers. It starts from 1 to infinity. Next comes outer circle. So this full small circle is natural numbers. Outer circle, next circle, second circle is whole numbers. Only 0 will be added. Remaining is there here. 1, 2, 3, etc. infinity. So 0, 1, 2, 3, etc. infinity is whole numbers. Then next comes Z, which is integers. All negative numbers, positive numbers and 0. So this full circle denotes Z. Next one, rational numbers, which are in P by Q form. So all these whole numbers, natural numbers, integers, every numbers can be written in P by Q form. So Q means full circle, everything will include. Rational numbers will include Z also, W also, N also. So whole thing will be written in P by Q, can be written in P by Q form. So they are rational numbers. So here, but irrational numbers are different. So that's why I have written in separate circle. Irrational numbers will not include in any of this. They are separate. All the non-recurring, non-terminating decimal expansions are called irrational numbers. Next comes real numbers. All rational numbers and irrational numbers together form real numbers. That means this rectangle represents real numbers. Real numbers are represented by capital letter R. Natural numbers are real numbers, whole numbers, integers, rational numbers and irrational numbers together form real numbers. Any real number can be represented on a number line. Number line, in previous classes you have learned, each and every point represents one number. So any real number can be represented in a number line. Every real number is represented by a unique point on the number line. Now this one, see this diagram, natural numbers inside. Innermost circle is natural numbers, next is whole numbers, next integers and next rational numbers. So all the numbers in natural numbers are whole numbers. That means 1, 2, 3, etc. infinity are whole numbers. So we can say that every natural number is a whole number. But just opposite, every whole numbers are not natural numbers, since 0 is the exception. Similarly, all the natural numbers are integers also, and all the natural numbers are rational numbers also, because you can write any number in P by Q form. For example, 5 you can write it as 5 by 1. But all the integers are not whole numbers. because negative numbers are not there in whole numbers. Similarly, all the rational numbers are not integers because integers doesn't have fractions. So every whole numbers are integers. It is true. Every whole numbers are rational numbers also. Next comes rational numbers decimal expansion. You know that numbers which can be represented in p by q form where q not equal to 0 are called rational numbers. So all the fractions comes under this. But what about the decimal expansion? Rational numbers decimal expansions can be either terminating or recurring. Either it will be terminating means it's stopping, for example 1.59, 1.23, 0.5 like this, etc. Recurring means it is repeating, numbers are repeating, for example 8.3333, etc. Here 3 is repeating. In short form you can write it as 8.3 bar. This bar represents that number is repeating. So rational numbers decimal expansion will be either terminating or recurring. Terminating examples are these numbers and recurring 8.333 or 9.535353, etc. That time you have to put 9.53, both number 5 and 3 top bar you have to put. That represents 535353, it's repeating. So these are the decimal expansions of rational numbers. Next we will pass on to exercise 1.1. First question is 0 is a rational number? Yes, answer is 0 is a rational number. 0 can be represented by 0 by 1 or 0 by any number or 0 by 9, any number in p by q form. These are all p by q forms where q is not equal to 0. So 0 is a rational number. It can be represented in the p by q form where q is not equal to 0. Second question is find 4 rational numbers between 3 and 4. For this, first you have to draw a number line with starting number 3 and ending number 4. So there are infinite number of points in between 3 and 4. That means there are infinite number of rational numbers are there in between 3 and 4. So to find the rational numbers between 3 and 4, first what you have to do is you should add the number, that is 3 plus 4 divided by 2. So add the number divided by 2. So that is 3 plus 4, it is 7 by 2. So this 7 by 2 you can mark it as here, 7 by 2. So 7 by 2 is a rational number which is in between 3 and 4. So this is the first answer, a rational number in between 3 and 4. Next we can find a rational number in between 3 and 7 by 2. How to find? The same method you have to adopt. Add the number 3 plus 7 by 2 and divided by 2. I am writing this division like this. So divided by 2. So add the number and divided by 2. That is 3 plus 7 by 2. One is a fraction, one is a whole number. You have already learned how to add the fractions and whole numbers. Use that LCM method. LCM here it is 2 only. So write that 2 down. So each number you have to multiply with LCM. That is 3 into 2 plus 7 by 2 into 2. Divided by 2, don't leave this. So 3 into 2 is 6 plus this 2 and 2 you can cancel, 7 by 2 divided by 2. So 6 plus 7 by 2 divided by 2. Now this division of a fraction, you can change it to multiplication. 6 plus 7 by 2, here this is 6 and this one 2 and 2 cancel, 7 by 2 and divided by 2, this divided by 2 same. Now 6 plus 7 is 13 by 2 you can write. Now this division divided by 2, division of fraction, you can change it to multiplication and take the reciprocal of the second number. This is 2 by 1. So reciprocal means just ulta you have to write, that is 1 by 2, which is equal to 13 by 4. 13 into 1, 13, 2 into 2, 4. So 13 by 4 is the next number in between 3 and 7 by 2. You can mark it in the number line 13 by 4. So now we got two numbers in between 3 and 4. These both are rational numbers. So in between 3 and 4, two numbers you got. Next, third number. You can take 7 by 2 and 4. In between 7 by 2 and 4, one rational number you can find. Same procedure you have to follow. Take both the numbers 7 by 2 plus 4. Both you have to add, divided by 2. That equals, here again you have to take LCM. 2 is the LCM. Each number you have to multiply by LCM. 7 by 2 into 2 plus this plus 4 into 2 divided by 2. 2 and 2 you can cancel. Remaining it is 7 plus 4 2s are 8 divided by 2. Division of a fraction, you can change it into multiplication and take the reciprocal. Equals 7 plus 8, it is 15 by 2 into 1 by 2, which is equal to 15 by 4. So which is the next rational number? You can mark it in the number line. In between 7 by 2 and 4, you can write it as 15 by 4. So now you got three rational numbers in between 3 and 4. One more rational number you have to get, because in the question they have asked 4 rational numbers between 3 and 4. We can take these two rational numbers, 13 by 4 and 7 by 2. In between these two rational numbers, we can find one more rational number. So here also you have to take the LCM. LCM method you have to follow. So 13 by 4, first rational number. Next rational number we have taken is 7 by 2. So add the numbers and divided by 2. Add the number divided by 2. Same procedure you have to follow. Here LCM you have to take 4 and 2 LCM. You know it is 4 only. So mark down that 4. Each number multiply by the LCM. 13 by 4 into 4 plus 7 by 2 into 4. Cancel this 4. 2 and 4 you can cancel by 2. Next, divided by 2. This divided by 2 at any cost you should not forget. Next, 13. Here it is 1. So 13 into 1 it is 13 only. Plus 7 into 2 it is 14. Divided by 4. This division by 2 you can change it into multiplication by taking reciprocal. So 2 by 1's reciprocal is 1 by 2. Equals 13 plus 14, it is 27 by 4 into 1 by 2, which is equal to 27 into 1 is 27. 4 into 2 is equal to 8. So 27 by 8 is in between 13 by 4 and 7 by 2. You can mark it in the number line. In between 13 by 4 and 7 by 2, you can represent 27 by 8. So 13 by 4, 27 by 8, 7 by 2 and 15 by 4 are 4 rational numbers in between 3 and 4. Similarly, you can find infinite number of rational numbers in between any two given numbers. One more sum I will show you. Third question. Find 4 rational numbers between 3 by 5 and 4 by 5. As the previous sum, you have to draw a number line, mark 3 by 5 and 4 by 5 at the extremes. Now you have to find 4 rational numbers in between 3 by 5 and 4 by 5. Same procedure, add the numbers and divided by 2. So that is 3 by 5 plus 4 by 5 divided by 2 equals. Since the denominators are same, numerators you can add. 3 plus 4, it is 7 by 5. This division of fraction, change it to multiplication and take the reciprocal. So 7 ones are 7, 5 twos are 10. So 7 by 10 is the first rational number in between 3 by 5 and 4 by 5. So mark that 7 by 10 on the number line. Next we can take 3 by 5 and 7 by 10. In between these two, we can mark one rational number. So for that, you have to take 3 by 5 plus 7 by 10, add the numbers, divided by 2. Take the LCM, 5 and 10, LCM is 10 only. So each number you have to multiply by LCM and then divided by 2 equals, you can cancel 5 and 10 2 times, 10 and 10 1 time. So 3 twos are 6 plus 7 by 10 divided by 2, which is equal to 6 plus 7, it is 13 by 10, division of fraction, change it to multiplication by taking reciprocal. So the answer is 13 by 20. Mark it on the number line. In between 3 by 5 and 7 by 10, you can mark it as 13 by 20. Next, in between 7 by 10 and 4 by 5, you can add these two numbers, divided by 2 and continue the same process. Hope you understood the sum. Now some homework sums I will give. Find 4 rational numbers between 1 and 2. Find 4 rational numbers between 7 and 8. Find 2 rational numbers between 1 by 7 and 2 by 7. Find 5 rational numbers between 2 by 3 and 4 by 3. All the sums, same procedure only. Add the two numbers, whichever number you are selecting, then divided by 2. Don't forget the division by 2. And fraction comes, you have to take LCM and add it. Thank you, children.